So is it about core and Shapley value in week 9 and 10?
Week 9 and
No,
week 10
not
was
in
for,
LLM. It's in
yeah,
GT,
one,
game
one
theory.
was for about auction, if I'm not wrong.
Okay. First price auction, second price auction, and
Yes,
multi-price
yes.
auction.
And networking effect.
Right.
So week 9, which question?
Question
Week 10.
week 10, question 13.
Okay, week 9.
No, 10, 10.
Okay, week 10, question number
Yeah.
13. My screen is visible?
Yes.
Yeah.
Okay, so this question is basically from the conceptual part. So revenue equivalence theorem says, let's open it here. So, okay, revenue auction, this equivalence theorem says that in all types of auctions, your seller payoff should be is equal to n minus 1 divided by n plus 1 into V max. Okay. So in this case, it was not coming the same amount. So it says, is it inconsistent with this theorem? So equivalence theorem says only expected payoff. So this is the catch conceptually. So your if actual payoff is not coming this, it does not mean that it is inconsistent. It just gives you expected payoff. Is that okay?
Can you repeat it one more time? If
Yeah.
the values that we got from the previous steps of this question.
Yes. So this theorem says expected payoff is n minus 1 divided by n plus 1. And in the lectures, he had taken the v is equal to 1 uniform distribution from 0 to 1. Okay. So this theorem says that any type of auction takes place, the seller's expected payoff will be this much. Okay, now here what we saw, we had okay, Kamla, three types of auctions took place, and then in every auction she was getting different amounts.
Yes.
Okay, so first was the first prize. First prize, okay, if I'm not wrong, she got around 0.6. Okay. In the second prize auction, she got 0.7, and the third prize here was 2 by 3 and 0.9 cube plus 0.7 cube plus 0.2 cube. So he is asking that are your answers about revenue received by Kamla in different auction scenarios inconsistent? So as per this revenue equivalence theorem, your payoff should have been the same again. But there is a catch again. This theorem says only about the expected payoff. Whereas okay, here, what are they? They are the actual payoff. So it is not inconsistent. Okay.
What would have made it inconsistent? If
Uh,
the so these values
so
0.6,
it means it is not inconsistent. It is consistent with this.
Oh, okay, so we calculate the value of n minus 1 divided by n plus 1 V max.
No, no,
And
no.
what?
We don't have to do that. They are just asking that by as per this theorem, your okay, payoff should have been same.
All the
But
three values.
yes, but revenue equivalence theorem is about expected payoff. It is not about actual payoff.
Okay.
Okay, that's why it is not inconsistent. Okay.
Okay. Yeah,
Okay.
yeah.
Yeah. Okay. Any other question?
Yeah. Uh, week 9, question 1.
Nine question number one. Okay. So this again we will revise again because this is if this question comes, then the concept should be clear. So there is a community of 1,000 people. In 1,000 people, there are 300 type A and there are 700 type B. And this language is A, language is B. then everybody can speak and understand his or her native language. A native speaker of language A can learn B at a cost of CA, which is greater than or equal to 0. So to learn B, he has to have CA, and for B to learn A, the cost is CB. The value of anyone is 1. So if you learn a language and interact with other person, then your benefit is 1 per person. For what value of CA and CB would there be a Nash equilibrium in which nobody learned the other group's language? So we have to think about like this. For example, if a member of A learns B, then his total benefit will be how much? Presently, his benefit is 300 because he can interact
300.
only with 300. Now,
Yeah,
if he
300
learns
plus
B,
300.
yeah, 1000. Because if he learns B, then he can interact in his group also, and he can interact with 700 also.
Yes.
Okay. And what is the cost to learn? Akya? Cost to learn will be 300 into CA.
Right.
Okay. Now he will learn only when this his total payoff 300 this minus should be greater than or equal to 300.
Why is it 300 CA? He already knows A. He is learning B.
No. The CA is the cost of learning B.
Okay, cost of learning B. But
Okay.
why is it 300 CA?
Because if he mhm. Okay, so it will be 1000 minus CA. You're correct again. So it will be only CA. Is that okay?
Yeah.
Okay, thanks again. So for him to learn, this benefit should be like this. So if we take this minus CA becomes greater than or equal to 700, minus 700.
Yes.
Or we can say that CA should be less than 700.
Yes.
So if CA is less than 700, then only he will learn B. Okay. So for any CA which is greater than 700, he will not learn B.
Yes.
So we get the condition for CA so that nobody learns.
Okay, so when CA is greater than 700, no one from this A tribe will learn language B.
Yes. And similarly, now we check for B. Now, if B learns A, his benefit becomes 1000. His cost will be CB, and it should be greater than or equal to 300. Sorry, 700.
Yes.
Okay. So from here we get minus CB 300 or CB less than.
Can you mention one more time why it is 1000 minus CB is fine? Why
Yeah.
it is 700 on the right hand side?
Because his current benefit is 700 for B.
Okay. So
Okay.
only when the benefit is greater will he make some changes.
Yes.
Okay.
So 700. So here he will get CB less than 300. He will learn A. Okay.
Yeah.
Now, therefore, for CB greater than 300, he will not learn. So for CA greater than 700 and CB greater than 300, nobody will learn. Okay.
Yes. Yeah.
Nobody will deviate it. Okay. Yeah. Then shall we go to the second question?
Yeah, please.
Okay. Just give me a minute. Now, second question is about socially efficient. Am I audible?
Yes.
Yes. Okay.
So, hi, sir. Sorry to interrupt you, but
Hi.
yeah, will there be any session on LLM?
LLM में क्या we are keeping a session tomorrow, but today after doing all this game theory, we can discuss some concept. Is that okay?
Okay. So tomorrow there will be some session, right?
Yeah, tomorrow we'll have around 7 o'clock. And basically, if you see, mainly there are theoretical parts.
Uh-huh.
So what I intend to do, I intend to cover the main concepts of week 11 and 12, as there was no material for week 9 and 10. And then go over all the main concepts of all the weeks. And then take some questions from GAs, tricky questions, and from the PYQs.
Okay, some selective question we will do.
Yes. Okay. Okay, so let's do this GT first. So this is an outcome is said to be socially efficient if it maximizes total benefit minus total cost. For what values of CA and CB would it be socially efficient for type A to learn B? So there is a catch here. They are asking only that what are the values of C and CB so that it becomes socially efficient, and only A learns B. B is not learning A. So what will be the conditions on CA and CB? So now consider that all members of A learn B. So what will be the total benefit? So total benefit will be that A are how many? 300, and B are how many? 700. Now all these 300, they can interact with 700. And all these 700, they can interact with 300. So this is the total benefit. Is that okay?
Yes.
Okay. Now for all members of A to learn B, this should be greater than 300 into CA. Then only all the members of they will learn B. So that your total benefit should be the cost of all the members learning B.
Yeah.
Okay. Therefore, if we struck this 300, 300, 300, so you will get 1400 is greater than equal to CA. So for CA should be less than equal to 1400. So we have got answer for CA. Okay. Now we don't want B to do this. We want only A to do this. So we will take reverse. So if we take for B and he wants to do this, so again total benefit will remain same. And for B not to learn A should be less than equal to 700 CB. I have used not less than because we don't want B to learn A. Is that okay?
We don't want them to learn. Yes.
Okay. Now see the correlation of this total benefit. If we replace this by 300 CA, that CB should be this part we can replace.
Yeah, we are substituting.
We are substituting.
Yes.
So from here we get 0, 0, cut this, and we'll get CB greater than equal to 3 by 7. Is that okay?
What happened to the CA?
CA will come here.
Oh yeah, yes.
Okay. So
Yeah.
these are the two conditions that for CA less than equal to 1400 and CB greater than equal to 3 by 7 CA, only CA will learn for the maximum, A will learn B for maximum social benefit. Is that okay?
So this was all of it was one question, that only A was learning and B was not learning.
Because here in the question they clearly asked that it would be socially efficient for type A to learn language B.
Only, yeah.
Okay. So this was
Yes.
the question. So these are the two conditions. Shall we see the next question?
Yeah, please.
Okay. This is an easy one. Okay, so for what values of CA and CB would there be an equilibrium in which type A learned language B and the type B did not learn language A? So it is asking about equilibrium, not social benefit. So C, equilibrium will be CA learns B. So CA benefit is how much? 1000 minus CA or A, sorry. Is that okay?
Yes, yes.
And when A learns the language of B, it means B can interact with all the CAs, so his benefit is 1000 without spending any money.
Yes.
Now, for A to do this, 1000 minus CA should be greater than 300, his present benefit. So CA will become less than 700. So for CA less than 700, we will recheck a disequilibrium.
So we didn't require that second 1,000.
No, we didn't require because this is an equilibrium. No? Without paying anything, his benefit is 1000.
Yeah.
And he will go only, and his benefit to net benefit is this much, and he
Yes.
will do only when his net benefit is greater than his present benefit, and from where he gets CA less than equal to 700, A will learn B and we will reach equilibrium.
Okay.
Okay, now similarly if we do for CB, it will become exactly opposite. This will become 1000, this will become 1000 minus CB, and 1000 minus CB should be greater than 700, his present benefit. So CB becomes less than 300. Okay, we take
This
another.
is for this second part is for the point that B is learning A's language.
Yes, yes. Okay.
Okay.
Now this question is a tricky question, and I am expecting most likely this question will come in quiz from week 9. So we have to take this question. So in this question, there are three linguistic groups A, B, and C. A, B, and C. There are 500 type A, 300 type B, and 200 type C. Okay, and again the values are there that everybody has the same cost C. Now here it is CC. All C's are equal. The benefit of being able to speak to and understand any other person remains 1. For what values of C would it be true that there is a Nash equilibrium in which nobody learns any language other than their native tongue? Okay. So what we have to consider in this, that equilibrium will be 500, 300, 200 only if nobody is learning. If nobody learns any language, then this is the equilibrium.
Yes.
Now, to find the conditions for C, we have to check, for example, why A would like to learn B and why A would like to learn C. If A learns B, then his benefit becomes 800, cost is C, and it should be greater than equal to his present benefit, 500. This part understood?
The C that is given is the cost to learn any language.
Any language.
Okay, okay.
If A deviates, for example, to learn B or C. So these are the conditions. A to learn B, he will only go 800 minus C is greater than equal to 500. So from
Yes.
here, we'll get C is less than 300. First condition. Okay.
Yeah.
A goes to learn both B or sorry C, then it will become 500 plus 200, 700 minus C greater than 500. Here we get C should be less than 200, number 2. Or A goes to learn both B and C. Both B and C. So then his 500 plus 300, 800, 1000 minus 2C should be greater than 500. Third condition. So from
Yes.
here, C will be less than equal to 250. Third condition. Okay.
Less
Now,
than equal to 300, 200 and 250. So in general, can we say that C will be less than 200?
no. This is only for A now. Okay, we have to check for B and C also.
Okay.
So for A, we know that if cost is greater than 300, then he will not take any this action because 300 is the maximum.
Yes.
Okay, now similarly we do for B. Now we will check for B. So B can learn A, B can learn C, B can learn AC. If he learns A, benefit becomes 800 minus C should be greater than 300. Therefore, C is less than 500. He goes to
Yeah.
learn C, 500 minus C should be greater than 300. C should be less than 200.
200. Yeah.
AC, if he goes 1000 minus 2C should be greater than 300. So this will become C less than 700 divided by 2, 350. So these are the conditions for B. Okay.
Yes.
So here we can get that for C greater than 500, he will not go.
Yeah. Yeah.
Maximum condition. Okay. Now same thing
We
we
will
do
not go to learn
any,
these languages.
any
Oh.
language. Okay. And for A, we had got okay, how much? C greater than 300.
So this is like let's suppose a person from tribe A will not learn any language if the value of C is greater than 300.
Yes.
And
Okay.
the other one is like a person from tribe B will not learn if C is greater than. Okay, like that.
Yes. Okay. Similarly, now C A C B C A B. So C A becomes 700 minus C should be greater than 200. So we will get C less than 300 or 500.
Yes.
500 minus C greater than 200. So C should be less than 300. Here 1000 minus 2C should be greater than equal to 200. So C should be equal to 400.
400.
So
Yeah.
for him also C greater than 500. So out of all these C's, which C is the maximum? So therefore for C greater than equal to 500, nobody will debate.
Yeah, nobody will go to learn any.
Okay. And your what will be the equilibrium? 500, 300 and 200. So this is the value for C. Okay.
How did you find 500? Oh, those are the given values.
Yes.
Yes.
Okay. Now just a reminder that here this answer which is there, it is given incorrect. But if you see the GA solution, there they have written correctly.
Okay.
Okay.
Yeah.
Okay. So this is one question okay, which I thought I should cover. And okay, we'll cover these basics also because on this question also it can come. Week 9. This is week 9 or week 10?
9.
Okay. Okay. So they have given a utility function u of theta was equal to theta into a plus v and e. Okay, this utility function generally, if you see the lectures, it is given as u theta is equal to a plus theta v and e. And the meaning of this formula is that any person who enters the market and for the networking effect, this A is the value, his benefit without any networking effect. This is the networking effect. Okay. And this any which is there, this is the expected number of users. Okay. That any person who's entering is expecting that these will be expected numbers. This is the value with every number and this is the function theta. But in this question, they have given a different that, no problem. So see, if you are paying, this is the utility and you pay something P price P.
Yeah.
Okay, so they have given a price P, given expected will be So your net benefit will be theta A plus V and E minus P. Okay.
Now, what is this value?
This is his net
Utility.
benefit. Utility minus how much again he is price again. So this is benefit minus cost to get the net benefit.
Net, yes, yes.
Okay. Now this theta which is there, theta with this top, he's an indifferent guy. He's an indifferent consumer. Okay. So for him, this value, this becomes 0. He can enter, he cannot enter. He may enter, may not enter. So from here, when you use this is equal to 0, you put top. And from here, you will get what? P is equal to theta A plus V and E. So theta will become P by A plus V and E. Is that okay?
We are just solving for theta.
Yes. So steps, okay, please remember these steps. So first you compute net benefit. Net benefit will be equal to utility function minus P. Okay. Then second you calculate theta dash by putting u theta dash minus P is equal to 0. Okay.
Yes.
This is an indifferent person. Now your demand formula is n is equal to 1 minus theta top. So this will become 1 minus P over A plus V and E. N is equal to 1 minus P over A plus V and E. Is that okay?
What is this? N represent? N represents the demand.
N is the demand, the present number. What will be the present number in the network? How many people are there? Users are there.
And N is always equal to 1 minus theta.
1 minus theta top. This is an indifferent person.
Yes, yes. And then whatever we got from the previous step, we'll plug it here.
Yes, so we
1 minus
get
theta.
yes, so we'll get A plus V and E minus P divided by A plus V and E, and if you calculate P from here, then it will become P is equal to, it will come here, A plus V and E minus N into A plus V and E, and this you can write 1 minus N into A plus V and E. Okay, this is the P. Okay. Now, fourth concept is that at optimal, when N becomes equal to NE, okay, when your demand becomes equal to the number of expected users. Is that okay? So at
demand equal to the number of optimal users, which is NE.
Yes. I'll give you an example. You're having a mobile, one app comes on the Google Store, okay?
Yeah.
And you want to purchase that app. So you will purchase that app, okay, with two minds. One mind, for example, it is a message app, okay, like WhatsApp, okay, some clone of WhatsApp. First, you will see its immediate utility to you, okay, that how much, okay, it is giving you benefit. So this is the A, okay.
Yes.
Second, you will see that in the future, how many of your friends and relatives, okay, they will be on that, okay, message app. So that is the expected number. You are expecting some numbers, okay. This is the N.
That is NE. Okay.
That is N. Okay. So we keep on finding now at optimal what happens. Now this app, okay, some people are downloading. So when people are downloading using, so that is the N. That is the demand. Okay. And when it reaches your expectations, you are expecting some that your 1,000 people will be on this, okay, for your benefit. So that is the optimal. N becomes is equal to NE. And that time we can write P is equal to 1 minus N into A plus P into N. Do you replace NE with N?
Yes, yes.
Okay. So this is the last question, okay, they have asked. So I will just go through the answers, okay, what they are asking. So first they asked, what will be the value of theta dash? Okay, so we have calculated P over V, A plus V and E.
Yes.
Okay. What is the maximum value of P to have buyers? So maximum value of P to have buyers. So what we have to do, P is this again. This is the value. P is equal to A plus V and E minus N A plus V and E into N. Again, this we can open. And for maximum, your delta P, we can have a derivative with respect to N.
Yes.
So this will give me minus A plus V and E.
Yeah, correct.
Okay, and this becomes secure. So just let me check what they have asked. A plus V and E. The maximum value of P to have buyers will be A plus V and E. A plus V and E. Just. Shall I open my that? Okay, I will just open. This is week 9, na?
Yes.
Okay. Maximum value of P. How did we calculate? I think some derivative we had to do. Okay, so theta dash has become here, and we got okay, from here, and value we got, P value we got, optimal we got, and we got A plus V and E. Yes. And the second part was, what is the maximum value of P? Okay. Okay. So this this part okay, which we got 1 minus N and A plus Vn. Okay, this is the part here. So now remember this N which is there, maximum your pay or price which is there, as the N increases, your price decreases. So maximum price is when N is equal to 0. Max P at N is equal to 0. Okay, and you can relate it to your real world also. When you are purchasing, only one user is there, he pays more. As the number of users, customers, they increase, the price keeps on decreasing. So maximum P, if you will put okay, here, N is equal to 0. So you will get P is equal to 1 plus V and E. Max P is equal to 1 plus V and E, which is coming from here. Is that okay?
So we are saying that when P is increasing, the value of N is also increasing.
No, no. When N increases, P decreases. And they are asking in the next question here. So that again we can check from here only. This is the formula we have got. So you can find the function between P and N and P and NE. P is equal to A plus V and E minus NA minus NV and E. Is this okay? Now we want to check relation between P and N and P and NE. So for delta P by delta N becomes this 0 plus 0 minus A minus V and E. So this is minus A plus V and E. Now remember, these both terms are positive. These are positive. Therefore,
Yes.
delta P by delta N will be negative.
Yeah.
And what does it mean? That when N increases, your P will decrease. Okay.
Yeah.
And similarly, we can check the relation between P and NE. This will become 0 plus V minus 0 minus NV. So this is 1 minus NV. Okay. Now N which is there, delta P by delta NE n will always be greater than, or just hold on. I have done some mistake. V minus n v. This I have written correct wrong. V minus n v p into this value which is there. This is always positive. Okay, value is positive. Is that okay?
Yes, this is the V.
This is the value. So we had got a plus v n e minus n a plus v n e. We take derivative with respect to n e. So here we will get only v, and this is 0, this is 0, and this will become only n into v. So
Yes, yes.
v minus nv.
Yeah.
So here v is equal to v1 minus n. Now there is a catch. There is some catch in this. There is a catch. V into 1 minus n. Okay. Okay. So in this this n which is there, we always take n is between 0 to 1. Okay, demand function which is there. It is like in the percentages. So this value which is there, delta p by delta ne, will always be greater, will be always positive. Okay, only at any it will become 0. So at that it will flatten out. Okay, they reach the maximum value. At all other places, this delta p by delta ne is positive. Therefore, when ne, your expectation is more, your price will be more. So it is also real world example, and very, very like for the iPhone. Okay. So number of users are purchasing iPhone, you are expecting more to purchase. That's why you put a price more. Okay. Is that
Yeah.
okay? Okay. So
Yes, yes.
so these were the only questions. Okay. So important question from here is this one, okay, utility function wala. You should know the steps. Then these three groups which are there. This is important to find the what will be the maximum value of C so that again nobody deviates. Okay. So these are the two important parts. Rest all is easy.
Yeah. Thank
Okay.
you. That makes week 9 a lot more clearer.
Yeah. Any other question from anywhere, or we can start with the LLM?
Would you mind explaining only the first question from week 10?
First question of week 10. Okay. Okay.
Yeah, I mean the e-based question.
Okay.
The concept also is little unclear, so I thought it would help.
Okay. Okay. No problem. Okay. So this is a. So basically, if you go through the eBay auction, it is like a second price auction. Okay. So you were here and you bid, okay, for example, or your original bid was X, okay, and you won the bid. The second bid which was there was Y. So you pay only Y.
Right.
Okay. Now they are saying bidding more than your valuation is weakly dominated by actually bidding your valuation. So it means instead of bidding here, this was your actual, you had bid and you won. But now you are bidding, for example, X dash, which is more than X again. Okay.
Right.
So still you will win the price, still you will win.
Yes.
And how much you will pay? The same value Y. So this Y which is there and this Y is there, it is the same.
If we are bidding
They-
X dash, will we still pay Y or will we pay X?
No, this is you. Instead of X, okay,
Okay.
your second
Right.
bidder, he remains at Y only.
Yes, yes.
Only, for example, I give you an example. You are in auction. He has bid 100. You bid 200. You won and you paid 100. Okay. Now instead of bidding 200, now you have bid okay 300. So still you will pay 100 only.
Yes, irrespective of that, we will only pay 100. Yes.
100 only. So therefore, what is a weakly dominated? when you pay the same amount.
Is it like x dash weekly dominates x?
Yes, because both are having the same value, na?
Yes.
Okay.
I thought it was strongly dominated because no matter what the amount x dash and x have, we will still pay y. Is that
They are still paying y. So weekly dominated का meaning क्या होता है? For example, we have seen those any examples कि आपका जो payoff है, is it as equal as the same? If this would have been 50 and this would have been 100, then this was strongly dominating this day.
right? That makes
Okay,
sense.
so
And when will this case be strongly dominated?
it will never be strongly dominated. It will be strongly dominated in what? It will be in the first price. Okay, so first price, you bid 300, you win the bid, and you pay 300. And now,
Yes.
for example, instead of 300, you bid 500. So you are paying 500. So in this case, this one who's there, he's strongly dominating this one.
Yes.
Oh, okay. So this is the basic concept in this question.
That makes sense. Thank you.
And the second question is also the same concept. Second question, shall we see the second question?
Yes, please.
So second question is again on the concept only, that bidding less than your valuation weakly dominates. Now see, if you are bidding, so again take this x and y example only, x, y, 100 and 200. Now he is saying that bidding less than your valuation weakly dominates. So if x dash becomes 50, you lose, you don't win.
Yes.
Okay, so that's why this is false. Okay, because in one of the scenario, he's not dominating. You're losing. You're not getting anything.
Okay, yeah. So right. The valuation is at 100, and when we are bidding less than that, we will lose. Yes, that makes
Yes.
sense.
Okay. Yeah. Any other question from any week?
Can you mention in the same question?
Yeah.
Earlier, suppose we had bid 100, now we are bidding 50. So, what is dominating what?
Dominating means that if you dominate, weakly dominates, it means you are getting the same benefit. Okay. So now
Yeah.
you take a case of first case, you bid this y was 100, x was 200, you bid 300, you win the bid and pay 200, pay 100 only.
Yes.
So in both the scenarios, outcome was same.
Yes.
So this scenario is weakly dominating this x second.
Yeah. If you are bidding higher than whatever we bid previously, that is weakly dominating that.
Yes. Whereas in this case, x is 200, y is 100. Now you are bidding less than your true value, so x dash can be 50. So your
Yes.
outcome is different now. You are losing.
In that case, we might not win all the time.
Okay.
Okay.
This guy will win. Okay.
Yeah.
Okay. Any other question? From
Week
any
12, week 12, question 14, Lalitji.
week 12?
I have understood.
Okay.
Yeah, I have understood when there are 2 players, but when there are 3 players, it is a little unclear about.
Okay. So in that basically the professor had not covered in detail that how to do that, and that was a confusion. So how to do this kind of questions? There are fixed steps. They are asking only that whether it is consistent or not with the contested garment principle. So what
Right.
in this steps are what? First member 1 comes, for example, first creditor will come. He will claim how much? 150. Claim
Yes.
150. Now how much is uncontested? Uncontested is 250. And this can go to 2 and 3. But we don't know how much it will go.
Right.
Okay, but if you consider this 2, 3 as one player, then it will go, 250 will go. Now leftover is how much? Is 150. this will be shared between player 1 and these player 2, 3, which we are considering as one player. So player 1 will how much he
One
will get?
second. This
Yeah.
leftover 150, like 250 is unclaimed. That can go
Unclaimed.
to either of the players. That is fine.
Yeah.
And this 150 is being claimed by player 1. So why are
Play-
we sharing it between them?
Okay, he's claiming, but when you do for these 3 players, only that is the line steps again we have to take care to check whether it is consistent or not.
Okay.
Okay, so this 150 which is there, now this will get shared again between 2 members because 2, 3 we are considering as one member. So player 1 will get 75. Okay,
Right.
so this was for player 1. Player 2. Player 2 will come, he will claim how much? He'll claim 200.
200.
Uncontested 200 will go to 1, 3, and we are considering them as one player. Leftover
Right.
is how much? 200. This will get shared between 2 and 1, 3. So here 2 will get 100.
Can you mention one more time why this leftover gets shared
Uh,
and not claimed by the single person?
Single person because there are 3 members here. Okay. And
Yeah.
in the contested garment, always we consider 2 members. Okay, one
Yes.
person comes, okay, second person comes and they contest, then we do. For when the players okay, increase to 3, then these are the steps, okay, how do we do that?
Okay, okay.
Okay, so here 2 will get 100. Now step 3, we don't have to go to the player 3. Now player 3 will get remaining. So 1 has got his share, 2 has got his share, and player 3 will get 400 minus 100 plus 75 is equal to 225. So if we do like this, then this allotment which is there, it is consistent. The word okay, important is that whether this is consistent with the contested garment principle. So this is consistent.
Yes.
Okay.
Understood. Yes, yes.
Okay.
So whenever we just have to keep in mind that whenever there is 3 players, we have to consider the other 2 players as one player and then keep sharing whatever
Yes.
we have left over. Okay.
Yes. Okay. Any other question? Search engine.
can you-
Have you understood the search engine concept? Okay.
No.
Oh, okay. So search engine, okay, I will just explain in by taking an example. So Google has got 3 slots, for example, Google search engine, okay, which is there. So this is A, this is B, this is C. These are the slots, okay, which are when we do Google search. So first 1, 2, 3, they come on top. They're sponsored ones. It means they have been purchased ones. So every this slot which is there, they have got like a click rate. Click rate means that if you are at slot A, then it is assured that at least it will be clicked 10 times. B will be clicked 5 times. C will be clicked 2 times, for example. Okay. Now,
Yeah.
there are 4 business houses. Okay. We take uh, just an example. I will take Geo, BSNL, Airtel, and Idea. Now, for example, for every business house, they know that if they are at this place, then how much revenue they will earn. For example, this guy feels that I will earn a revenue of 4 if I'm at Alpha, A slot. If I'm at Bravo, my revenue will be 3. C, he will think, okay, my revenue will be 2. Okay. Similarly, BSNL thinks that my this is take some example, 2 here, 1 here, 1 here. Okay. Airtel thinks I will be 3, 2, 1. Idea thinks I'm 1, 1, 1. It doesn't matter to Idea. Is this example real world example? Okay.
Yeah, yeah.
Now the question is that how much value Google should keep for these slots. He will do the auction for these slots. So if you think logically, first I will come to the socially optimal question. There was a socially optimal question in that. So socially
Yes.
optimal value, the first slot should be going to the bigger revenue. So Geo should be here, and how much he will earn? 4 into 10, 40. Second
Those are
slot,
per click.
हाँ जी,
Those are per click. Like 4
yes,
is for 1 click.
4 for 1 click per click. Okay.
Yeah.
Second slot will go to whom? Now we have made some changes here. Let I change this to some values to make it. Okay. Now the second slot to whom it will go? Now this guy is left. Now second slot will go to this guy,
Airtel, yeah.
Airtel. And how much he will earn? 2 into 5 is equal to 10.
10, yeah.
Third slot can go to Airtel, or Airtel is gone, Idea.
Idea.
So he will earn 1 into 2 is equal to 2.
2, yeah.
So this is the socially optimal value, that you charge 40 for the first slot, second slot 10, and third slot Idea 2. So here is your 52 is your socially optimal.
For having these 3 ads.
Yes, 3 ads.
Okay.
But what is that? Okay, VRG or something VCG pricing? Okay? So that pricing means that the first slot will still go to G only, but
This is the VR
VRG, na,
pricing.
there was some function was there, na, total value VCG.
VCG.
Yeah,
Yeah.
VC, Vikrel, that. So VCG pricing, how we find the pricing. So still see, first slot will go to G only, but value of this slot will be how much Geo has harmed other competitors, has harmed other players. So see, if Geo was not there, then who would have been at the first place?
Airtel.
Airtel. Very good. So Airtel would have been the first slot. And how much he would have earned? 3 into 10, 30.
30, yeah.
And how much he's earning presently?
10.
He's earning 10 again.
Yeah, he got the second lot and he got 10
Okay.
in the socially optimal.
Okay. Just I made one mistake. Sorry. My apologies. Okay. So these revenues which are there, it will not make any difference. These revenues are per click. Geo knows that any user, when he clicks on his site, he will earn 4. Airtel knows I will click 3, Idea knows 2, and BSNL knows 1. So these are not per slot wise, these are per click wise. My apologies.
So no matter who clicks on Geo, I mean, in which slot they click on Geo, they will earn 4 per click.
Yes, they know that any user who will come to his site, likely he will convert to a consumer, and per click his average revenue is 4 rupees.
Okay.
Okay.
Okay, yeah.
Okay, so it does not make any difference to anyone. Okay, so here again we had made a calculation error. This will become 4 and this will become 54. So if you do an auction, Geo will so these are the revenues. Geo will take the first slot, Airtel will take the second slot, Idea will take the third slot. Okay.
When Geo takes the first slot, it is 4 into 10. When Airtel takes the second slot, it will be 3 into 5, right?
3 into 5. Sorry, that's why
Yeah. And Idea got 2. Yeah, 4.
So 15. Okay. So this is a socially optimal if the question comes.
Okay.
Okay. Now to find what should be the value, VCG value, we check how much, okay, if Jio was not there, then what would have happened? Then Airtel would have been at the first place.
Yes.
And presently he's at second place, his revenue is 15.
15. So he
So-
made 15 loss.
So difference is 15.
Yeah.
Okay. Second, okay, now we come to Idea. Idea is at third place, but he would have been at second place. So he would have earned 2 into 5 is equal to 10.
2, 5, 10. Yeah, yeah.
And presently, how much he's earning? 4.
4. Yes.
So
6.
harm to Idea is 6.
Yeah.
Similarly, BSNL, presently he's earning 0. He's nowhere.
Yeah.
But if Jio was not there, then sorry,
He
BSNL
would have been third.
third, and he would have earned 2.
2. Yes.
So total harm done by Jio is how much? 15 plus 6, 21 plus 2, 23. So this should be the value which should be for the first lot.
Value for the first lot. Okay.
Okay, VCG value. Okay.
Yeah.
Okay. Now we come to, for example, second slot again. So they will ask again. So we copy from here only. So second slot presently who's there? Airtel. And third slot is Idea. So now we check for second slot how much Airtel has harmed. Airtel has harmed Idea and BSNL. Is that okay?
Yes.
So Idea presently he's at third place and his revenue is 4. Okay.
Yeah. Yeah. Yeah.
Now if we would have been at second place, then his revenue would have been 10. 2
2
into
into
5.
5. Yes. Yes.
So harm done 6.
6.
And BSNL presently he is nowhere.
Yeah.
But if the Airtel would not have been there, then
He
he would have
been
come at
third.
third place.
Yeah.
And he would have earned okay, how much?
2.
2.
It was 1 into 2 or 2 into 2?
1 into 2.
1 into 2.
BSNL is 1 and then that is 2. So
1
2.
into 2, na? So
Yeah.
it will become 2. So for second place value is how much?
8.
And third place is easy. Third slot presently Idea is there, and we'll check only harm done to BSNL. So it will be same 1 into 2 minus 0 is equal to 2. Okay. So price for this lot will be 23, 8 and 2. Is that okay?
So
The
Google will
VCG.
Yes.
So Google
Yes,
will
yes.
decide the prices of the slots to be 23, 8 and 2, is it?
Yes, yes. So they will keep a price for slot 1 as 23, this as 8, and this is as 2.
And if it was socially optimal, what for each slot Google should have put 59.
Yes, again, that 59 value which we got. Because
59 for each.
4 into 10, no. 4 into 10, 40 for the first slot.
Okay,
Second
right.
slot, 3 into 5, 15. And 2 into 2 is equal to 4. So 40 for first slot, 15 for second slot, 4 for 3 slot. And total is 15.
Okay.
Is that okay?
Yeah.
In real life, does Google come to know how much the others are willing to pay? Like the value 4, 3, 2, 1, where that is coming from?
They are hypothetical examples, but they must be carrying out, all these market surveys and business analysis studies and all that.
Okay.
And this is just one theoretical part again. So in our this, they have just tried to explain that how this pricing is done when there are slots.
Okay.
There might be more to it. Okay. Now, when the Google knows that Jio is ready to pay 40 rupees, his Jio benefit is 40. Okay, it is not Jio is willing to pay. Jio knows that if I am at first place, then my benefit will be 40.
Yeah. Per click.
Per click is 4 rupees. So if he is at first slot, he will get 10 clicks.
Yes.
So his
So his
benefit will be
total
40.
profit will be 40.
40. Okay.
Okay.
Any other question?
Just curious, the questions that we had in quiz 1, quiz 2, with all the like the subjective ones with a car going through a passage or some those kind of questions, is there any probability of them being repeated?
Okay. So yesterday we had discussed okay, that cargoing is very easy. That okay, we can do because you can go through that video. That revision session is available. And yesterday we had solved that quiz 2 question. That two
Oh,
political parties when they spend time on the whatever their
is
publicity.
that video up yet? Recently, I saw the end term video.
Uh, Anthem video for game theory has not. Yes, yesterday we had okay, one Anthem. So that has been uploaded.
Yeah, I watched that.
Yes, yes. That okay, is there. So political party question has been solved okay, yesterday.
Yeah. No, political party is clear. I understood it from the video. I
Yeah.
was asking ki, is there any possibility of the road and the highway, that kind of question coming?
That bridge question, na?
Yeah.
So if it comes, just go through that okay, revision. You'll get okay, idea.
Okay.
Okay, so it was like 45, 145. It was something like that, na? So when is the
Yeah.
equilibrium? And when you build a bridge, what happens that everybody will take second this. Okay, because time to reach here, this is opposite 145. This is 45 1. And when you build the bridge, then the time here is 44. So everybody takes a bridge. Okay, that becomes equilibrium.
Yeah. Yeah.
Yeah.
Okay.
Okay.
Thank you.
Yeah, welcome. Okay, LLM. Okay, anyone from LLM here?
Yes, I am having LLM, but I have not started the prep yet.
Okay, so tomorrow we'll be having a LLM session, and what we see. Abhinit, any discussion you want to do on LLM? Abhinit is there, but he might be waiting. Okay, both of you have got LLM.
Yes, Lalitji.
Okay. So LLM, can we just have the discussion? Okay, Abhinit will also join. So today I was doing LLM. Okay, this. Okay, so I was going through the basics again. So for the week 12, okay, if we see, it was about positional encoding. And positional encoding has got two types, okay, absolute positional encoding and relative positional encoding. And in the absolute, okay, we have got the sinusoidal one, which we had seen, okay, I think during week 5 or week 4. And the second one is the learnable, where, okay, for example, like we used to have the learnable, that embedding matrix, which is there. So similarly here we learn. And the second is the relative, because it was explained that if the words are far away, for example, or they are appearing here, so your relative information should also be there. So how that relative is done, so this I have explained in this document. You can go through that. It is just an example. So it is mainly theoretical, like nothing, to calculate, or some tips are there to solve that question. So you just have to go through the slides, or you can go through this document. So that is there. Alibi also I have solved, like one example I have given how that is done. Abhinit, are you there?
Yes, yes, ma'am.
Yes, sir.
Yeah, Abhinit, any discussion on week 12 you want to have?
12.
Yeah.
For GT, I don't have GT.
Okay,
No,
no,
for
I'm saying about LLM.
Okay, for LLM, week 12 is clear to me. Week 11 is not much clear.
Okay, so we come to week 11 only. So week 11 is about number of computations first. Okay? So a number of computations is clear, okay, when we do a
Yeah.
multiplication. Okay, so just for the benefit of everybody, so matrix multiplication, how do we do that? There is a matrix A, its size is P into Q. There is a B, and this is Q into R. So here, if you do, and then you'll find that your number of multiplications which are there, it is p square into q. Okay, and when you do the additions, it is p square q minus 1. I will just take an example of 3 into 2 into 2 into 3 matrix. So 3 into 2, 1, 1, 1, 1, 1, 1. So this is 3 into 2 matrix, and 2 into 3, 1, 2, 2, 2, 2, 2, 2. So you see here, it will become 1 into 1 plus 1 into 1 into 2 into 1 into 2. And then 1 into 2 plus 1 into 2, 1 into 2 plus 1 into 2, same again it will happen. So you see how many multiplications are taking place. Here 2 multiplications are taking place at every step. So there are 9.
18.
So 2 into 9 is 18. So if you consider from this formula, so this is 3 square into 2. Is that okay? And if you check and if you check the additions, how many? 1, 2, 3, 9 additions. So this is 3 square, 2 minus 1. Okay.
Sir, for above line, you have written P cross Q into Q cross R. That should be PQR, if I'm not wrong.
No, I'm saying number of multiplications. This is the number of multiplications. Okay, because yes, PQR. You're right. Here, P and Q and R were the same.
Yeah, that's why it's O of PQR is the
yes.
and complexity.
Yes. So the complexity of your attention matrix in the week 11, what he tried to cover, that week 11 only. So this complexity is O t square d. Okay, because here again we multiply t into d into t into t. Okay, so maximum complexity is O t square d. How to reduce this again? So the full attention matrix, the complexity is O t square d. And when we come to memory we say, for example, for a single sequence memories for MHA, this is the multi-head attention, how much we are storing. So we store Q, we store K, and we store B. So this is the T into D model. Because size of WQ, WK, and WV is how much? T into D. So this much memory, and there are 3. So for one multi-head attention, we need that. And if we are passing a batch, then total memory required is 3 TDB. Okay, so this is an example. So how to reduce this again? So what we can do? So he told us some concepts that when we do the full attention, that entire Q, entire K, entire V they are doing, then this is the full attention we are doing. So first concept is that we do some local attention with a value of C. And C means, for example, if C is 3, then he will attend only, for example, only immediate word hereafter and thereafter. If C is equal to 5, he will attend 2 Ks here, one query, and 2 Ks here. So this is the meaning of C is equal to 5. And when we do this C, then your complexity becomes how much here? CTD. Is that okay, Vinit?
Yeah.
Okay. So this is when we do the fixed here. Second, we can do it with a stride also. That instead of immediate, what we will do in this here, for example, C is equal to 3 and run C is equal to 3. So he will attend second last checker and maybe third most checker. So this also can be done. And in actual, what happens that when you have got a number of heads, for example, is equal to 8. So in one head, you apply this C is equal to 3. So you're attending this. Second, you attend to different. So finally, when all the heads they are doing, so you are attending all the words, and that's how we reduce the complexity also. Okay. So then was the dilated. Okay, this second example was a dilated example. Then third was a global plus local. So there he said that you take one token which will always be attended to. For example, CLS in the BERT. We know that CLS in BERT is very, very important. So this token will always be attended. And for rest all, okay, we will have okay, this dilated or the local attention only. Then there was a block attention concept. So block attention concept, what do they do? That your entire T which is there, so T, for example, T size is, for example, 16. So it is divided into blocks. For example, we divide it into 4. So your entire tokens which are there, so your Q which is there, it is having 4 blocks. Your K which is there, it is having 4 blocks. So when you do, this is Q and this is KT. This is also into 4 blocks. So when you do the blocks, how do you define the block? So you will write okay, like this, pi 1, 2, 0, 3. And what is the meaning of this? This is very, very simple. First of all, you write here Q1, Q2, Q3, Q4. They remain standard. Q1, Q2, Q3, Q4. This is K1, K2, K3, K4. Now here this 1 means K1, 2 means K2, 0 means, for example, this will become, sorry, K1, 1 is K2, 2 is K3, this is K1 and this is K4. So,
Right.
so Q1 will attend to K2, Q2 will attend to K3, Q3 K1 and Q4 K4. So this is the example. So in one head they are attending like this. In second head they will do another. So by this also your complexity decreases. So this is the most common attention mechanism which is applied. Okay, this is clear because this was a question which was confusing in GAs.
GA, this question was not confusing. For me, the first question, M flop, was confusing.
Okay, so M flop, yeah, so M flop is easy. Okay, so this I have done. So M flop, okay, I will directly come to the GAs only. And if we don't remember even a formula, we can do that. Okay, and that's why I covered okay, this multiplications and the addition parts. Okay, okay, we should know that how many multiplications are doing and how many additions are doing. So he had given T is equal to 1024, D model is 512, DQ, DK, DV is equal to D model, and one flop for a single mathematical operation such as addition and multiplication. So see, we know that in one attention matrix, what is happening? We are doing Q into KT. So we are multiplying T into D into D into T. So now we know that number of multiplications will be T square D and number of additions will be T square D minus 1. Is that okay?
Yes.
So these are the number of flops okay now. So number of flops will become 1024 into 512 into 1024. So this was the flop okay, 1024 square 511 this one. This is 512 and here okay, you 2 by 511 D minus 1. And for M flops, you divide by 10 to power 6. Okay, because 1 mega flop, M flop is equal to 10 to power 6. So by doing this, okay, you get the correct answer. Okay, so flop is nothing, but it is one operation.
Yeah, I can. Oh, I forgot that. Yeah, it was a part of memory allocation where each flop is actually taking the bits count for either taking an operation or not taking an operation.
Yes.
Like for any of the microprocessors.
Yes, yes. Okay. Now, second was also very easy. What is the amount of memory required to store these pre-attention scores if we assign 16 bits per number? So now you see attention matrix size is how much T into T? So this will be 1024 into 1024. These are number of values we have to save. And for every value, we want to give a precision of 16 bits. So this becomes 16 bits. Now to convert it to byte, okay, you divide by 8. Okay. And now to convert it to KB, you divide by 1000. Because 1 KB is equal to 1000 bytes.
Right.
Okay. So this was again simple. Now, third was, suppose we want to reduce the complexity of the attention module in an encoder part of a transformer, that is OT square, to at max OT square by 2 using a local attention mechanism. Then which are the following C values they had given, okay, I think 768 also, these were the options,
Right.
can be used. Again, they studied local attention helps achieve this objective. So how I approach this problem, I said that with C, your complexity is OCTD. This is the complexity.
Right.
And when you do your normal attention module, he's saying T squared by 2, but it means T squared D by 2. Because your
Right.
complexity is T squared D. So it means this TTD which is there, it should be less than T squared D by 2.
Yes.
And now you can cancel, okay, this T and T and T and T, and you do the multiplication, this mathematics. So your C will become less than equal to 512. So for all the options, your complexity is at max, okay, T square by 2. But 768
Right.
was not the answer. Okay.
Right. Also, other method you have given, like we can like take T square by 2 for
Yes.
the given parameters, and then we can compare the size as well.
Yes, yes. Okay, so this is again, okay, just now I explained, okay, how to solve this. This is a child scale. Okay.
Yeah.
So this was not a problem. Okay. Now this is a question from the concept, and again from the slides only. The statement that both a low rank approximation, that is C, of attention and a local attention low rank approximation, sorry, this is C, and this is, okay, K, when we were doing the K, has the same computational complexity when K is equal to 1 and C is equal to 1. So see, for both low rank approximation and local attention, your computational complexity is KTD and CTD. So at K is equal to 1 is equal to C, the complexity is the same. So this part is true. Okay. But here, therefore, both approaches always end up computing the same representation for the given tokens in a sequence. This is false. Okay, because in C, you are only paying attention to the C values. Whereas in this K, he attends, okay, all the tokens. Okay, but he is finding that, okay, K, he is using that, okay, HVD wala principle in that. Okay, so your complexity is same, but final representations will be different. Okay? That's why it was false. Okay, question number 7, I think it is the last question. Suppose we decide to use KV caching mechanism for faster inference. The details of the text generation as given. What will be the minimum size of cache memory in MB such that it should cache at least 512 tokens? So this is also a very, very easy question. We don't have to remember the formula. So
just
see,
multiply everything and multiply by 2.
yes, so we find for K, for example, what will be the size of K, and V size will be the same. So K size is how much? 512 into D.
Right.
And straight away we can find, like, a D from here, 512 into 512. Okay, so we don't have to consider this like a number of heads and 8 into 64.
Right.
Okay, because finally the K size will be that only, the number of values. So KV will become 2 into 512 into 512. Okay.
Right.
And now there are number of layers, okay, for example. So
For every layer, it should be 512 into 512, so that will be multiplied by 16.
By 12. Number of layers is 12. Okay.
Yeah.
Okay, and he has given precision also. So now every value should take 32 bits. Okay.
Right.
Now change it to byte by dividing by 8. And now for NB, you divide by 2 to the power 6.
Right.
NB, 10 to power 6, sorry.
Into box 6.
Okay. So 10 to power 6, okay, answer comes 25.16 megabyte. So we don't have to remember any formula. Okay? Just okay, if we go logically, you'll get the answer. Is that
Right.
okay? Yeah.
Yeah.
Okay. So that's all okay, from week 11. Any other thing okay, from week 11 you want to discuss?
No, not currently, because currently I have clear with week 11. And
Okay.
week 12 is pretty much clear.
Okay. So week 11 and week 12 are clear, and week 10 and week 9 we don't have any theory. So I will suggest to everyone. I have gone through the PYQs. A lot of questions are there from the concepts. Okay. So please try to understand the concepts, how those attention matrices are being formed, block, attention. Okay. And you don't have to remember any formula other than this formula. What is that formula which was there? NC by N alpha by beta plus DC by D
By D
and
whole
beta.
to the power beta.
Beta. So this is loss. And NC is 88 trillion, means 88 into 10 to the power 12. DC is 54 trillion, 12. Alpha is 0.075 and beta is equal to 0.096. So this is the only formula from, I think, week 8. Okay, this is the question.
Yeah.
Okay, so that might come. And only one insight is there from this formula, that always remember that if you have more parameters in your model, then you need more data to train.
Right.
Needed to train.
Because otherwise it will become self-consuming data
Yeah.
itself.
Yes. It will become overfitting. Okay. Any point taken from week 11, week 12? Anyone wants to contribute? Chalo, then shall we call it off for today?
Sure, sir.
Yeah.
Thank you, sir.
Thank you.